Okay, so here we have some examples of graphs. So I'm going to go over three examples. You might be looking at something like this with a hole in the middle. You might be looking at something like this with a hole in the middle and a dot somewhere else. You might be looking at two pieces that don't connect, one with a solid dot, one with an open dot. I'm going to run over those three real quick. How do we do those? Well, um, first question is, determine which of the following rules for continuity is violated first at x equals 2. So we're here at, x equals 2. That's, this is the x-axis at 2. So we're talking about that point right there. And so, and this is the function f, right? Graph is the function f. So, so at x equals 2. So, or I guess they mean a equals 2, whatever. So a is 2. F of 2 is defined. Which of these is violated? Yeah, see the answer key down here? F of 2, so we click that. F of 2 is violated. How about um how about this though? How about the limit as x goes to a of f of x exists? Does the limit exist there? Or is that violation as well? Well, the limit does exist because as long as the limit from the left and the limit from the right hit at the same height, they both hit at a height of 2, then it exists. So that one's not violated. This one's okay. And how about, does the limit as x goes to a of f of x equal f of a? Well, um, yeah, f of a is not even defined. So, yeah, so I guess that's what we're saying. F of A is not even defined. So that's the first violation and problem. F of A is not even defined. All right, let's go on. It's kind of a little bit of a different question. How about this one? Okay, select the statements below that you agree with. Um, you may be checking more than one box. Okay, let's see. So here's our function. First off, is f of 2 is defined? In other words, is there a value at 2? Yeah, it's right there. So check. And you can see it down here. There's the answer key. Yep. Next one. The limit as x goes to 2 of f of x exists. Does the limit exist? It does. We're going to check that box also. You can see it's down here. Why? Because from the left and from the right, they're meeting each other. As long as the from the left side and the right side meet at the same height, at a height of 2, then the limit exists there. How about the next part? The limit equals f of 2. No, that's not true. Um, because f of 2 is right here. This is f of 2. F of 2 is -1. It's down at a height of -1. So the function at 2 is actually down at -1, whereas the limit is up here at 2. So the limit is up at 2. F of 2, though, is -1. So they're not equal. No, we don't agree with that. Okay, next one. The function is continuous at x equals 2. No, continuous means that you don't pick up your pencil. So for example, that means a function is continuous. If you could start on the left, draw the function all the way and never pick up your pen. Well, whoops. Right here, I'd have to pick up my pen, go down there, and then come back up here and finish. So that's not smooth, not continuous. So we would actually check this box, not continuous at x equals 2. Check, not continuous at x equals 2. So we end up checking those three boxes. Okay, now last version. What if you have this version? Um, Same kind of thing. It says select all the statements you agree with. Okay. First off is f of 2 is defined. Yeah, f of 2 is right there. It's the solid dot. It's -1. Check. You can see it's checked down here. Next question. The limit as x goes to 2 of f of x exists. Does the limit exist there? No, because from the left side and from the right side, it's hitting at different heights. So it's got to hit the same height from the left and the right for the limit to exist. So we were going to say no to that one. Next one. The limit as x goes to 2 of f of x, well, it doesn't even exist. So right, this left side doesn't even exist. It's not even a value for it. You can't take the limit when the left and right don't meet. So that one's just automatic no. The next one, the function is continuous at x equals 2. No, it's not continuous. Remember, continuous would mean if you took your pen, you could draw from the left all the way, you'd have to jump down here and then go like that, right? You'd have to pick up your pen and jump down here like that. If you have to pick up your pen, it's not continuous. So we're actually going to check this box, not continuous, not continuous. There we go. So no, those are the ones we check. So there we go. There's the ideas of continuity and limit being the same from the left and the right.